Hi everyone, welcome to this masterclass where I will be showing you how you can effectively use PyMOL and get publication quality images that actually you can use in your research papers, in your review papers. We will be using PyMOL and the features, hidden features of PyMOL that actually will give you high quality images. And in this particular tutorial, I will be showing you how you can get the structure and then how you can change the visualization of the ligand molecule. In this one, we will be focusing on ligand and protein interaction. Those who are not aware of this, ligand and protein interaction is the interaction of a protein molecule with its drug molecule. Right? Most of the time journals, they ask for this interaction in the form of a 3D image. And in that one, what you actually show is a ligand and then what are the interacting molecules in that particular protein. And by showing the information associated with that also, for example, hydrogen bonds, and you also will show the residues and their names, you can actually, create a wonderful map that will be appreciated by reviewers. So in this master class, that everything I'll be covering is going to give you a skill set that effectively using PyMOL, you can create a very good quality images. Myself, Dr. Lokendra Kumar, I've been working in this particular area. I'm doing research in biotechnology, computational biology for almost more than decades now. And I've published so many research papers. And also created one resource for all of you called Research Goal, where we have a lot of courses that you can complete, and you can get trained on all those skills, even if you don't have any kind of programming experience, any kind of competition experience, right? So there are so many things we have in Research Goal. I request you to visit the website and please look at that. And in this masterclass, I'll be showing you some of the glimpse of what we offer in Research Goal. So it will help you understand what kind of quality, what kind of material that we provide on Research Goal, right? So with that note, let's move on to the tutorial part, and I'll be showing you all the commands, and the script that is been created right over here is available on Research Goal, and you can actually get the course on Research Goal, especially on protein molecular visualization, protein editing, where you will find all these kind of scripts freely available. You can download them and you can effectively use them for your research. All right, everyone, let's start with the tutorial. All right, let's get started. We'll start with getting the structure, getting the protein in the PyMOL. So as you can see, this is the interface for PyMOL, and please, I'm sure you have the PyMOL installed. Open up the interface and follow along. If you follow along, probably you're going to learn better, right? So in this one, we will be knowing how we can create publication quality images using PyMOL. There are so many things you can do. We'll start with the basics, right? So we'll start with getting the structure of the protein. And I'll also open the text file, and I'll show you what are the commands that I'm following right over here. You can actually see this will be my first command, and we will populate this file so that we understand what are the commands that we have used. We'll start with fetch space the name of the protein. So this is the four-letter PDB ID, protein data bank ID, and from there PyMOL is going to get this particular structure. So if you just copy this one, okay, and then paste right over here in the command line and press enter, you can quickly see that we got one protein structure right over here. And let me tell you what that protein is. This protein is called human estrogen receptor alpha, in short ER alpha. And this protein has a ligand molecule which is bound right in this pocket, as you can see. Let me zoom in a little bit. Look at that, right? But as you can see, when we get this structure in PyMOL, everything is in a same kind of color. You cannot actually see what are the other things that are there. Some of the representations that are really not of the publication quality, right? So what you do is you actually change this layout and create a publication quality image in PyMOL. And for that, what you do, I'm going to tell you that one by one, right? And depending upon what you want to show in your image, you can actually keep that stuff. What you want to remove from this particular image, you have to remove that. For example, most of the time you don't need water molecules. For example, I'm going to use another command, which is the removal of the solvent molecules. In this case, most of the time they are water molecules. There are different ways, but I'm telling you that this is the command you can use. Just copy that, okay, and then paste it over here. Before running this command, let me show you what difference it's going to make. Look at these star asterisk signs or plus signs. These are the solvent molecules. When I run this command, immediately you will see that those molecules, now they are gone. That means we have removed the solvent molecules, and you can see it is much cleaner, because we are not interested in solvent molecules. If you are interested in solvent molecules, then you keep them and show them in a different representation. Now, to create a good quality image, let's hide everything and then start showing things one by one. But before that, I want to remove unwanted things that are there in my structure. So for that, I need to see the sequence. To see the sequence, I have to go down right over here and click on the S button that is mentioned, which is the sequence tab. And I want to just see whether I have a complete sequence and what are the extra things I have. So as you can see right over here, the first one is the ligand molecule. If I click on that one, you will immediately see it got selected. So that I want to keep. But there are these additional molecules that are also present. I'm going to select all of them and just remove them. I really don't want these molecules. These are probably coming from the crystal structure when it got crystallized, or I don't want to show them. Then I'll just remove these from clicking from this particular structure, going to remove atoms, and as you can see, they are gone. Okay, wonderful. And it depends upon the project to project what you're doing, and you might maybe in that case you want to keep them. But anyways, I just showed you that how you can remove the unwanted things from this particular structure. All right, now let's hide everything. So the third command that I'll be using is this. Let me paste it over here. Hide everything. Simple, right? So it's gonna hide everything. If I paste it right over here, enter, as you can see, it's gone. It's gone, right? Sometimes sometimes you get lost in the PyMOL window, and you can try to come back by right-clicking going to zoom widths. This usually keeps the things in the center. If you don't have anything, it's not going to have any reference, so you cannot have a specific coordinate, right? So that means everything is hidden. Okay, now let's show the protein structure. We're going to use the command called show cartoon. Okay, show cartoon command. You just copy that, type it over here, enter. Now what we have done is only the protein as a cartoon format. As you can see over here, there is no ligand molecule. Anyways, now for that also, we're going to change the transparency of this particular cartoon structure, right? You cannot be using this because maybe you're interested in showing the ligand protein interaction and you want to show the ligand. You don't want that messy springy structure to show in your images. So what you do is you just paste this command right over here and change the transparency. So I'm going to set space the transparency of the cartoon representation. So cartoon underscore transparency, comma, all those things are really important. Then space 0.8. You can change this value depending upon the value, the transparency is going to change. So let's paste it over here, enter. Look at that. Now it's much darker in color, which is what I wanted. Now let's color the protein. Okay. You can select any color. I'm selecting the gray color and specific shade that I'm going to mention over here. This is the command, which is color. I'm going to take a gray 80. This is the color theme that I'm going to use. And then I'm going to change the color of the polymer, which is protein. In this case, I'm going to enter that command over here. And then as you can see, it got changed. Now it's green color, right? Depending upon your interest, you can actually change this color into red, green, blue, whatever color you want. So we should be good. Now comes the point where we play around with the ligand molecule. Now, first we need to select the ligand molecule, right? For that, I have a command that I've already written so that it saves a lot of time from your side. This is the command, which is selecting the ligand molecule and the organic molecule, which is there. So I'll be pasting that, entering. As you can see, we don't have ligand right over here, but as you can see, we have selected the ligand. So ligand selection is done. Now the point is where we're going to show the ligand, and we're going to show the ligand in the stick format. I'm sure that you have the basic understanding of PyMOL. If you don't have the basic understanding of PyMOL, I highly recommend you to complete the courses that we have on Research Goal. Okay, so you can go to Research Goal right over here. This is the website that I have, right? And before moving to Research Goal, please do not forget to subscribe to the channel. And if you go down, there are so many courses that I've made, and I'm sure you're going to enjoy these courses if you have interest in computational biology, structural biology, And there are some courses that I made on, let's say, virtual screening in drug discovery. Very, very important, very very good course. You can do virtual screening. The main course that I want to show is protein analysis, editing, and molecular visualization. These two courses are going to give you a lot of hands-on training in PyMOL. Okay, so if you don't have basic understanding, please complete them, and then you can always see these videos, right, where I tend to provide some additional skills to my students, and so that they get much better skills on PyMOL and do really good kind of analysis. And by the way, many of these scripts I will already made them available in these courses, so you can directly go over there. These scripts are going to be there in the script section, and you can actually download them. For example, as you can see, I'm just creating this script, and finally you will see that script is there available. You can actually download very, very easily, and there are so many scripts that are available over there, right? Okay, now let's move further and let's show the ligand in the stick format, and this is the command show sticks comma ligand. Okay, we will just paste it over here. Immediately you will see the ligand is visible, right? Look at that. Now ligand is visible. It doesn't matter because the cartoon representation of the protein is not hindering the view, so you can see the ligand molecule because the transparency of the cartoon representation is now minimized. Understood that, right? Now let's change the color of the ligand and make it a different color, so that if you want to change it to a different color, you can actually use that command. So I'm going to change this to yellow color. I'm going to change it to yellow color. So let's go back and then put that command over here, press enter. Look at that, it's in yellow color. And sometimes if you don't want that, you can directly go over here where ligand is mentioned. You would go to see by element. You can actually change whatever color you want. Like you can actually see it's orange in color, so you can do both. Now let's zoom into the binding pocket. Okay, you can do it like this, but to get consistent result, you can actually use the command line. Next is this. So you can change this value depending upon how much zoom you want. Right here the value is 10, so let's go over here and paste it, enter. So it went actually zoomed out because we were maybe a little bit zoomed in, right? Let's change the setup and then rerun the command, and you will see it's going to come to that position. So every time your images, they are going to be there in this particular orientation, and your images are going to be consistent. Paying attention to the details is really, really important when it comes to high quality publications. All right. Okay, now what we're going to do is we're going to select the residues within a specific distance from the ligand. This is very, very important because now we are working in the area of displaying the interaction. Okay, so what is the command that I'm going to follow in that case is this. It's a big command, right? Okay, so I can zoom out a little bit so that you can see the entire command. It says select pocket. So I'm going to select all the residues, and the residues are going to have that distance 3.5 angstrom from the ligand. Okay, let's paste that, and immediately you will see it selected some residues. So all these residues, they are closer to the ligand molecule, and the distance is 3.5 angstrom. And now let's show these residues in the stick format, right? All right, look at that, show sticks in the pocket. Enter that, and all those residues, you can actually see how nicely the interaction is now we can actually see it visually, right? So we are right now we are seeing all those residues, but let's change the color of these residues, which we called the pocket, right? So basically we named all these residues as pocket, and what I'm going to do is I'm going to select that. I'm going to show you the command that I will be using, which is color cyan to the pocket. As you can see over here, the pocket is mentioned. So it's going to change the color of the pocket, and look at that. It's up to you, right? You can even change the transparency of this pocket, whatever you want to do. But anyways, I like that. So now they are a little bit, as you can see, it's also going to change this protein structure right over here also. Look at that, because some part of that amino acid is also present in the cartoon representation. So both of them, they got highlighted, but you can actually see. Okay, now let's see how many hydrogen bonds are there. This is one of the important command. Okay, how many hydrogen bonds are there? So we're going to have whatever distance we have for hydrogen bonds, we're going to identify if there is any hydrogen bond between the ligand and the pocket. Okay, so let's go over there and then paste this command, press enter. Look at that. You will immediately see interaction is now visible. There are two residues that are showing us the hydrogen bonding with the ligand molecule. And those who are working in drug discovery, they understand the importance of this information because these are the two residues that are playing very, very important role in binding of that particular ligand molecule with the drug molecule. Okay, now let's improve the appearance a little bit. For example, we need to change the radius, the dash radius, right? So you can also do that. Let me show you the command for this. Okay, let's go there and then create another row, and this is going to change the radius of the dash radius that we have actually seen, and I'm going to paste it, and as you can see, it's a little bit changed for our dash radius. And then gap, you can even change the gap that was default and to look a little bit better in appearance. And then this is the command which is set dash gap. And you can even change. I'm just giving you all those commands, and look at that. Now they are much closer, right? So it's visually more appealing, as you can see over here. Default value is not good. So if I change this to, let's say 5, look how different it looks. When I change it to 2.5, look, it looks much more interesting, right? So this is how you can change that, and I can change this into different color, right? So for that one, I'm not going to run that. Let's do that. Okay, I'm going to make it black because whenever you publish these findings, you're going to use the white background. So I'm going to use black color for that, which is not going to be quite visible in here, but you can clearly see the black color line is there, right? It's more visible when you are printing them on white background, which is most of the time background of the publication, right? Okay, now we're going to label the interacting residues. So many things we are doing in this particular tutorial. Okay, so we're going to now label the pocket, and we're going to name them, and you have the carbon alpha that we're going to select, and then this is the command that is going to entirely provide those residue names, and I'm going to just run it so that you can actually see what's happening. Initially there was no names, but now you can actually see the names, where you just zoom into one residue and let's see that. But the size of the name is very, very small. Look at that. It's very, very small, very, very tiny. We don't want that. Now let's play around with the visibility of the label, which is really important. What I'm going to do is I'm going to set label size. Okay, so let's set label size 22. Okay, see, I have already selected those numbers, and they are going to give you a little bit of better visualization in terms of seeing these names in the publication. You can even always change this number, right? So now let's change the color of the label, and we're gonna change the labels, and we're gonna make them black. I know it's not a good idea when the background is black, but as you can see, they are changed. And I'm going to use a specific font ID, lucky number 7. There are so many different font IDs, okay? But I'm going to use that, and I'm going to paste it right over here. Let me show you again what I did. What I did is I actually changed the color to black and changed the font ID to 7. Let's enter that. Okay, all right. I think I made some mistake. Yeah. Because the copying was not accurate, so it was not set. It was at, which is incorrect. So PyMOL gave me error. You can clearly see. Anyways, now the command is correct. Enter. And right now it's not quite visible, but as you can see, it is a little bit bolder and more professional in appearance, the font ID. Next is we're gonna improve the cartoon representation of the this is one of my favorite. Okay, this is one of my favorite change that I always do in my publications. So I want to use the fancy helices. Okay, so there are normal helices, and then there are fancy helices. Let me show you the difference. Okay, so as you can see over here, look at this. There is no folding of this from the corner. When I run this, you will immediately see what I'm telling you. So now I'm running it. Look at the difference. If I turn it off, should I do that? Let's do this. let's say off. See the change, right? See the change. See the change where this now folding is not proper. Folding is not proper. And here you can actually see the folding is on. Yeah. And if I zoom out, and you will see now the change in the appearance of these cartoon representation of these protein helices. Look at that. It looks much, much better. Okay. Believe me, it looks much, much better. And you can always improve the quality. I'll show you how to improve the quality. Anyways, now it's the time for us to actually change the background and see what we were doing so far is actually fitting for the publication background, which is white. Let's do that. Enter. Okay. It might surprise you because there was sudden change in the appearance of this particular structure. It got changed. So much light. I'm facing so much light on my desktop. Okay. Anyways, but it's much, much better. As you can see over here, you have these, the text on the residues, and then you also see the ligand. You also have the hydrogen bonds. You can always change the color. You have distance also. You can actually see, it's not quite visible, but you can probably see 3.2 is written. Okay. What else? You can also see the perspective view or orthoscopic view. Usually people like orthoscopic view. Let me put that command over there also. This one. So let's keep the orthoscopic view on. This is the orthoscopic view. And then let's remove the depth fog. Okay. These are some of the interesting command that will change your protein visualization significantly. So depth, I'm going to turn it off so I can actually see the protein structure in the background. Look at that. It was not visible before. So because depth Q was on, now it's off. For better lightning, oh my God, so many things we are doing. For better lightning, this is the command, which is ray shadows. Let's do the ray shadows on. Okay, let's do that. And yeah, ray shadow is on. Okay, next, let's smoothen out the edges, right? So let's smoothen out the edges, which is putting the command, which is set anti-aliases right over here, anti-alias as 4. So this is going to a little bit smoothen out our structure. And then background, if you want to make transparent background, which is good when it comes to creating your final image. So it will not show anything because I've just from white background made it transparent. Okay. And then if you want to do high resolution rendering, you can actually do that. I'll show you. But there are some things that you can clearly observe that there is some overlapping of the names, and that manually you can actually control, which is a powerful technique. So you can go to 3-button viewing to change it to 3-button editing right over here on the bottom right corner. And then be careful with this command. Once you do that, you can actually alter the structure. Okay. So please use this command when you're only doing the visualization. If you're using that structure further, do not use that because this might actually change some positions of the atoms. So carefully what you have to do is you have to zoom in and you have to select the residue that you want to move, right? For example, let's do that. Let's set which one? Select this one a little bit. Okay. And then move it. So how I'm able to move this a little bit so that the view is good is by pressing Control. As you can see, this you can do nicely, and then you can actually press Control, select the residues. As you can see, if you make mistake in that one, you end up changing the structure of the cartoon representation, which is incorrect, by the way, right? So you have to be very, very careful just selecting those names when there is nothing in the background, and then only move them. Okay, do not change anything which should not be changed. As you can see, so it's something it's really important, and this is something I want to change. Okay, and then you can oops, that's not good. You don't want to change when there is a structure behind this. Okay, that is doable. I don't want to spend too much time on this one, but as you can see over here, look at that interaction. People are going to love this because this is going to show them what are the residues that are there in the active site, what are the residues that are important. One important change that I recommend, go to settings, change the quality. Okay, so you can actually go to not setting, display, go to quality, and then maximum quality. Boom. This will enhance the quality of your structure. Now let's just stop here and then save this. So we can save this as ray slow, whatever setting you have. You can actually select the setting and maybe in some other videos I'll show you how to actually select the best quality for rendering. But I've used the default quality. I'm gonna move it to desktop, and this is my final image, and then enter and write your own scripts where actually you can get this kind of quality image by just running that script, and you should be able to get the customized view for your protein, right? Might take some time. When it is done, I'll be showing you the final image on a PPT file. Okay, as you can see, our image is ready. Let's save this image on desktop, right? Okay, I'm just giving random numbers. It took some time to actually so we have 2 images that got saved. It will look like this. Look at that. This is the final image. And what we can do is actually copy this image, open up PPT, right? Open up the PPT and then paste the image right over here like this. Got it? Like this. And the good thing is when you don't have any background, you can actually change the color of this particular image, and you can fill in any color you want. Look at that. Let's do a little bit of gray color or darker gray color. I don't know, whatever choice you want to have. You can change that, right? And then you just have to play around with what kind of coloring you want. You can crop this. Not crap. It's not a crap image. It's a good one, right? So you can crop it up and then put it right over here, and that can become the image 1 in your paper. Wonderful, isn't it? So always remember, there are quite wonderful things you can do with PyMOL. Some of the examples I've shown you, and we will be doing something else also that will enhance your skill in PyMOL. So please, try it out and see with your own protein molecule, with your own ligand molecule, how you're able to actually get the structures and have the visualization done like this. I hope you have enjoyed this masterclass where you understood how you can show protein ligand interaction. We have shown that in the form of 3D map. There are so many things we can do using PyMOL, and all the courses that we've created on Research Goal will give you all that skill set in computational biology, and you can effectively use those tools and become a better researcher. Even these courses are catered for UG, PG students, and you don't have to be a PhD student for these courses, right? Please do let me know what are the problems that you're facing in the comment section. If you have any issue related to your research project, please let me know. We create all kind of material in the channel, the teaching material, education material, research oriented material, and we also have career related material. So please, if you like the channel, then please subscribe the channel and be the part of our small community. I'll meet you in the next one. Till then, take care, everyone.